consider another quantity, resistivity. What is this resistivity? Resistivity means it is a characteristic property of a material. That means it is a material property. Depends upon the material property. So, where this resistivity came from? Just now we considered that R, the resistance, is proportional to L and inversely proportional to A, and thereby we have R is proportional to L by A, isn't it? This is the equation that we got, or rather the relation that we got. Okay. Now, since there is a proportionality, you have to introduce a constant, isn't it? So, now you have R is equal to rho into L by A, where rho is a constant of proportionality, which is termed to be resistivity of the material. Okay, so rho is that constant introduced here, which is termed to be resistivity, notated as rho. Okay, so you have R is equal to rho L by A as the equation. Fine. Now, when you consider this rho, the resistivity, we could say that that is a material property. As the material varies, rho also varies. Okay. And it is also dependent upon temperature. So, we can conclude that the resistance and resistivity both depend upon temperature, isn't it? Resistance and resistivity vary with temperature. And when you consider the value of resistivity, you could see that metals and alloys have low resistivity, whereas rubbers and glass have high resistivity. Okay, so metals and alloys are materials with low resistivity. Rubbers and glasses are materials with high resistivity. As I told you, that's a material property, characteristic property of material. Okay, now we know the equation for resistivity from this, isn't it? We can get the equation for resistivity. What will it be? R is equal to rho L by A, or rho is equal to RA by L. Isn't it? This would be the equation for rho, the resistivity. Fine. Now you got the constant rho. That's the quantity. That is a material property that we know. Okay, and it has got low value for metals and alloys and high value for rubbers, plastic, etc., glass, etc. Okay, and we got the equation for the same. Now, what would be the unit of it? Let's check. For that, let's substitute the units of each and every quantities, isn't it? That's what we do usually. So, resistance, its unit is termed to be ohm. Area means meter square. Divided by length means meter. So, 1 meters are cancelled. So, rho has a unit ohm-meter. Okay. So, that is the SI unit of resistivity, ohm-meter. Okay. You need not study it by heart. Just by substituting itself, you will get the unit, isn't it? So, you have the SI unit of resistivity to be ohm-meter. Okay. So, that is about the resistivity. And we know that the resistance and resistivity both vary with temperature. Okay. Now, you can see here that the resistivity of an alloy is generally higher than its constituent metals. Okay. So, that is a fact that you are considering. Metals and alloys have low resistivity, isn't it? Out of that, alloys have high resistivity comparing to metals, comparing to its constituent metals. See, if you are considering nichrome, nichrome is an alloy of nickel, iron, chromium, etc. Isn't it? So, you could see that when we compared the value of resistivity of nickel, iron, etc. in separate, the value of resistivity for those is less compared to the value of resistivity of nichrome as such. Okay, that's what is mentioned here. The resistivity of alloy is higher comparing to its constituent metals, with which metals the alloy is made. Okay, that's what is considered here. And we know that alloys do not oxidize readily at high temperature. Oxidizing means getting burned up in a way, isn't it? So, at high temperature, it does not get oxidized easily. That is a property of alloy. Okay, and this is the very same reason we make use of alloys as heating element in appliances like toasters, electric geysers, etc. Okay, in those electrical appliances, we need a heating element.